Hi everyone, in case you were absent, I just wanted to go over the last little bit on the notes for solving multi-step equations. Today we're focused on even more steps, but still combining everything together, combining like terms, distributive property, and variables on both sides, and then I'm going to talk about something else about different solutions. So our first example here, and the formatting is off just a little bit, but it's really example A, is 3 times the quantity of x minus 5 plus 1 equals 2 plus x. So remember, the first thing we always want to do is distribute. That's always the first thing. So 3 times x is 3x. 3 times 5 is 15. And we're going to put a minus there because there's a minus in between x and 5. Bring down the 1. Bring down the equals plus 2, or equals 2 plus x. All right, let's combine our like terms. And if I look at my equation now, I have a negative 15 and a positive 1 I can combine together. There's nothing over here on the right-hand side to combine because you can't combine 2 and x. That gives us 3x minus 14 equals 2 plus x. Okay, so now we have an equation with variables on both sides. So I'm going to move this x term, I'm going to move it to the other side, and we'll just subtract x on both sides. 3x minus x is 2x. Okay, and I know that I'm going to end up having to move this minus 14 over as well, so we'll add 14 to both sides. Again, this is kind of a recap of what we've done the last few days. All right, so minus 14 and positive 14 make nothing. 2 and 14 make 16, and plus x and minus x make nothing. So if 2x equals 16, x equals 8. All right, I'm going to do this next one here with you. That should really be example B. Apologize for the typos. We have 3/4 times the quantity of x minus 13 equals negative 2 times the quantity of 9 plus x. So we'll distribute the 3/4 to both terms inside our parentheses. Remember, we always distribute first. And we're going to have to distribute over here too, negative 2 times 9 times 8. All right, so 3/4 of x is just 3/4 x minus 13. So 3/4 of 13. And we can just grab our calculator. That gives us 9.75. And let's go ahead and just convert that to a decimal term. So 3/4 is 0.75. All right, negative 2 times 9 is negative 18. Negative 2 times positive x is negative 2x. So there we go. All right, let's move our variables over. Remember, there are two sides to an equation. Let's add 2x to both sides. And what that does is it eliminates the negative 2x. And let's add 9.75 to both sides. All right, so 0.75 plus 2 is 2.75. Minus 9.75 and plus 9.75 make nothing. Negative 18 plus 9.75 is negative 8.25. And minus 2x and plus 2x make nothing. Okay, so we'll divide both sides by 2.75. And we get a value of x equals negative 3. Okay, so even though there are fractions here, which we converted to decimals, it's still the same process. Take it slowly. There's nothing really new here. I'm going to leave example C and D for you to do, and you can get those checked off by me. One thing I will change on here is over here on example D. Change that to a 1/4. That might have, I think in hindsight, 1/3 might be throw you off just a little too much. Just keep that as a 1/4. Okay. Let's talk about different solutions. This is really easy. It's just a little concept I want you to know here. Equations can have one solution, and we've only ever seen equations that have one solution. There's only one number that would work for that equation. However, there are equations where there are no solutions. That means there's no number that would work for x. And there are equations where there are infinitely many solutions, which means that means every single number that you would plug in for x works for that equation. Okay, so let's look here. This is really example 3. It's a lot of typos. Example A, how many solutions does the following equation have? We have 6 plus 3x equals x minus 8. Okay, so here's a handy trick. If they have different variable terms and a different number term, then it has only one solution. Okay, and let me show you why. If we solve this, we subtract x from both sides. We'll subtract 6 from both sides to get that 6 over to the right side. 6 minus 6 is nothing. 3x minus x is 2x. X minus x is nothing. Negative 8 minus 6 is negative 14. So x equals negative 7. That's the only number that's going to work for x. So if you plug that negative 7 into the original equation, it's going to be a true statement. Okay, so let's look at what should be B. How many solutions does the following equation have? 8x plus 4 equals 4 times the quantity of 2x plus 1. So what you're looking for here is the same variable term and same number term. So if we simplify this, and right now it looks different, but if we simplify this, we get 8x plus 4 equals 4 times 2x is 8x, 4 times 1 is 4. Okay, so we see 8x plus 4 equals 8x plus 4. It's the same expression on both sides. This is a type of equation that has infinitely many solutions. You can abbreviate that as IMS. And lastly, how many solutions does this following equation have? And this is an example of something that has no solution. And what you're looking for here is the same variable term, but a different number term. And that's going to give you an equation that has no solution. So if we solved this, okay, if I subtract 3x from both sides of my equation, those all cancel out, and all I'm left with is 1 equals 6. Well, we know 1 equals 6 is not true. 1 does not equal 6. They're different numbers. So this is a type of equation that has no solution. All right, so there are different patterns you can look for, different variable terms, different number terms. They could actually have the same number term. Okay, as long as the variable terms are different, one solution. How many solutions does the following equation have for B? We have infinitely many. We're looking for the same variable and the same number term. And if you want an equation that has no solution, we're looking for something that has the same variable term and a different number term. Hope that helps. If you have any other questions, please come see me in class.